Hello everyone, this is the first lesson recording for IM1, November 17th in 2020. So what are we doing today? We are going to be quantifying why a line is the best fit. And we're also going to be writing equations of lines from 2 points. We're going to start with some announcements. Next class, you're going to have quiz number 6, and it is going to be on multiplying polynomials using distribution, scatter plots like association being positive, negative, strong or weak, or linear or nonlinear, and line of best fit, making predictions using graph and equations. So you need to be very comfortable with homework number 21, 23, and 24. And as you can see, you are going to be seeing some Spanish translation of the slides. They are going to be usually in green, so you can just ignore the green writing and focus on non-green writing. All right, so good line of best fit. We said that between all 4 of them, what do we look for? We're going to be looking for a line that follows the trend of the data, that it approximate equal points above and below the line, and pass through as many points as possible. This is general guideline, but it's not always going to be as possible. Okay, so using those guidelines, these 3 are no good, and A is the best line of best fit for given this scatter plot. Now we are going to try to quantify a line is the best fit. So we eyeballed drawing many different line of best fit last lesson. Okay, so there must be a way to say one is better than the other. So how can I represent the quality of the best with a number? So you are trying to quantify the bestness, if you can call it. And what should I measure in order to be able to say, conclusively say that my line is better than your line or whatever else? So to explore that, we are going to be working on Desmos card number 1 to 5. So please pause the video and try card number 1 to 5 right now. So this is the first card of Desmos. Okay, so which point? In your head, draw a line through the green points that fits them best. Which of the purple points does that intersect? Well, in my head, maybe the line could look like this. It could look like this. Could look more like this. There are many different points. Okay, so if I was sort of just draw it, my guess will be B. Okay, so that's my guess. And your guess might be different, and that is perfectly okay. So I'm going to click on B, and I am going to explain my thinking. Okay, so I want the line to be following the trend, so it's definitely going to go this way, and I want approximately the same number as above as below, and that is the line that I came up with. Okay, so imagine the line in your head continuing out to x is equal to 100. How high do you think the line will be at that point? Okay, so the line goes to when x is 8, x is 12, x is 16. So x is 10 is approximately here. Okay, so then if I was to say, okay, if I was to imagine my line, looking something like this. Okay, so let's just say that's what I imagined. Then let's see how much it changed from 0 to 10. It went from, I would say, from here to 0 to 10, it went to here. Okay, so that means it increased by almost 4, but not quite 4, maybe 3. Okay, so maybe 3 units up. Okay, so it increased by 3 units up when x changed by 10. So if I multiply 3 up by 10, that's going to be by 100, that's going to give me 3 times 10 is 30. And to that, it looks like I am going to have 0.5 in the beginning. So x is going to be approximately, for me, 30.5. That's my guess. Again, your number could be quite different, but just think about how you would calculate that. Okay, so you might calculate for every 10, how much did it increase, and then multiply by that by 10, or so on and so forth. Okay. Okay, this is card number 3. Now this time, which line? Drag the movable points to create the line of best fit you are imagining. Okay, so I can move those black dots. Okay, how does this look? Okay, so maybe about there. And I said it will go through B. Okay, maybe it should go through C to be a little closer. Okay, I don't know. And again, yours might look very different. I am kind of going through 2 points, but two are very much below, whereas two are very much a little bit below, but two are very much more up. So maybe I should move that a little further up. Okay, so maybe it's going to go through B. Okay, but I still want it to go through at least 1 point. Okay, so that's my line. Okay, let's move on. Okay, so they've actually redrawn the line that I drew. So this is the line that I drew, and yours might look very different. Here's the line you created in the previous slide screen. What did you decide? How did you decide on that line? What is your technique? Okay, so I am looking to follow the trend, first of all, and it seems to be increasing from left to right. And I am looking for, I don't know, about the same number of dots below, but actually that didn't quite work out because there are 4 below, but 2 above. So that's really no good. Okay, but that's okay. Let's see how it works out. Okay, the equation of your best fit line is y is equal to 0.274x plus 0.902. So the Desmos has calculated for us. Use that equation to calculate how high the line will be when x is equal to 100. Okay, so that means I am going to substitute 100 into this equation. Write your calculation here and press submit. So, okay, so let's do the math. I am going to do the substitution. So y is equal to 0.274. And instead of x, I am substituting for that x to be at 100 plus 0.902. Okay, if that is the case, I am multiplying 100, but that just means I am going to move the decimal place 1, 2. So it is actually 27.4 plus 0.902. So y is going to be um, 7 plus 9 is going to be 36.0. Oh, okay, my bad. The correct answer should be 28.3. Okay, so 28.3. That's what I should get according to my graph. Okay, what was yours like? And yours might look very different to mine. Yours might be, I don't know, closer to 20, maybe it's closer to 40. There will be quite a big range. Okay, so from our Desmos exercise, everybody created their different lines, and there was quite a bit of difference when it came to when x is equal to 100. As well as how can you tell whether my graph was better than somebody else's graph? Well, there has to be a way because we want to be able to quantify and say that this is the line of best fit. So I am going to introduce the idea of residual. Okay, what is a residual? Residual is the difference between observation and prediction. That means residual is the error of prediction. So in this case, I have, okay, so in this case, look at this, I have the residual from my line and the data points were the green. Okay, so the data points were green and that data point was right on the line. So the residual, that means what I predicted that was on the line minus what actually it was the same point. So that means the residual is 0 because there was no difference between those 2 points. The next point is a little easier to demonstrate. When I look at this, how far is this green point? Remember, the green points are the data points that I was trying to draw my line of best fit. So to do that, I am going to calculate how far is this line, this point, from the line of best fit. It's like that. Okay, so that's almost like 2 whole units, a little less. So that blue point represents that from 0. So it is above my line of best fit, so it's going to be positive, and it is almost close to 2. So that is the reason the blue line is close to 2 from 0. Okay, then let's look at the next one. Okay, so here is a green point here, and this from my line of best fit, it's actually going down. It's going down. That means it's going to be the residual is going to be negative. So it is like whole 1 unit below. So I am going, that is the reason that my blue point, which represents the residual, is 1 unit below. Okay, what about this point from the line of best fit? It's very, very close, but it's just slightly below. So this is why it's just slightly below the x-axis. And here, looking at this, how far am I? So I am like 2 whole units plus a little bit more. That means, and it's above, that means it's going to be positive. So 2 whole units plus a little bit more, and that's where my residual dot is. This is approximately 1 unit below. So that is the reason that my blue dot is about 1 unit below here. So the blue dots represents the residual. The green dots represents the actual data points. And just like I said, residual can be positive or negative depending whether the dot, the data point, is above your line of best fit or below the line of best fit. In this case, it will be positive. The blue dot is a positive side because it's that many unit above the line of best fit. In this case, the green dot is below the line of best fit. So that's why the blue dot is below the line of best fit by 1 unit. And you are going to continue with card numbers 6, 7, and 8. Okay, so please pause the video and try to follow this. This is card number 6, and it says introducing residual and drag the blue points to plot the residual. So the first one has been done for me. The residual is the difference between the actual value, that's the green dot, and the predicted value of x value. That means that's my line of best fit. So how far is my green dot from the line of best fit here? It's just slightly below, so that point, the first blue point, is slightly below for me. Okay, so now we need to do the rest for the other points. When I look at this, I see that the green dot is 1 whole unit and maybe 1.5 units up. So it's going to be 1.5 units up. So it's going to be up here, something like that. When I look at this point, it's 1 whole units down plus a little bit more. So I am going to move it down here. And this green dot is just slightly, maybe like 1.5. Okay. And this green dot is like 1.5 above the line of best fit. And this green dot is below 1.5. Okay, so that's going to be my guess, and check my answer, and it's going to start drawing the line And mine